For this problem, we are looking at, this is from the partial fractions section here in Math 126, section 5.4. And so we're looking at breaking this apart into two different fractions. As you see, here's the answer. But let's talk about how we get there. Now, when we do something like this, we can say our fraction x over x minus 3 times x minus 2 equals, and I'm going to break this out to say it's a over one of these, x minus 3, plus b over x minus 2. Now, why did I choose a and b? Well, we want to come up with some variables here, and we're looking at x minus 3 is one of them, x minus 2 is the other. Not trying to be redundant, but trying to explain, though, that the numerator is 1 degree less than the denominator. So the denominator is linear, so the numerator is constant. Same thing here. That's linear, so this is constant. And then we go on from there. If, for example, I had something like x over x squared plus 3 times x minus 2, it would be ax plus b over x squared minus or plus 3 plus c over x minus 2. So notice that this is 1 degree less than down here. And if we had something like x over x minus 3 squared times x minus 2, we would have a over x minus 3 plus b over x minus 3 squared, so it still stays as a constant, plus c over x minus 2. So understand that how this breakdown occurs in doing the partial fractions. But the problem at hand is this here. So what I'm going to do is multiply by the common denominator, which is x minus 3 times x minus 2 times x over x minus 3 times x minus 2 equals a over x minus 3 times x minus 3 times x minus 2, that's over 1, plus b over x minus 2 times x minus 3 times x minus 2 over 1. And then, obviously, these divide out. These divide out. This divides out with this term, or factor, I should say. That factor divides out with that one. And so a lot of people will skip that step and just realize it's going to be x equals a times x minus 2 plus b times x minus 3. And there are a couple ways to go about this part. The quick way is, well, in this case, because these do have zeros. If that was like x squared plus 2, it would be hard to do it. But if you said x equals 2, we'd have 2 on the left equals a times 2 minus 2 plus b times 2 minus 3. Well, that's just 0. So we have 2 equals negative b, so b must be negative 2. Oops, scroll, there we go. And then for the other one, if I said x equals 3, notice I chose x equals 2 because it made that 0. I didn't quite say that, so I apologize. So if I make the other term 0, so 3 for x equals a times 3 minus 2 plus b times 3 minus 3. So again, that's going to be 0. And what are we left with is that 3 equals a times 1, so a must be 3. So that leads us to it becoming, so this was what, x over x minus 2 times x minus 3. I know that it's not the same order, but multiplication is commutative, equals 3 over x minus 3 minus 2 over x minus 2. And that is what they have there. Good. Yeah, I got it right. Now, I want to show one other thing. And give myself some more workspace here. So when we're back at x equals a times x minus 2 plus b times x minus 3, another way you could have done this, and this is more related to the system of equations, is you'd have x equals ax minus 2a plus bx minus 3b. And so this is what I call collecting the coefficients. I'm not sure what the actual title is, but I'm looking at coefficients for x. The coefficients on the left would be 1. On the right, it's going to be a plus b. So a plus b is 1. And then for the constant, on the left, it is it's 0, excuse me. On the right, it's negative 2a minus 3b. Okay, and sorry, let me give myself some more space here to work. And now we have a couple ways of going about this. Like we can multiply this first one by, let's multiply by 3. We'd have 3 times 1 equals 3a plus 3b. Then we have 0 equals negative 2a minus 3b. I chose 3 because I could have chosen negative 2, or could have chosen 2 or 3. Could have chosen anything really, but to be effective, I chose 3 because that gets rid of my b's and keeps things positive. So 3 equals the a. And then I have that relationship described above, that 1 equals a plus b. So 1 equals 3 plus b. So b equals negative 2 if I subtract 3 from both sides. Okay, so that's another way of getting it. That's using the system of equations and that addition technique to solve that system. So, okay, a little longer than I know people like, but I was trying to show 2 different ways. I hope that helps. And let me know if you have questions. Thanks.